So Bree, given the email yesterday that said that they're opening back up kind of with COVID and everything, is the Navigation 2 still going to be in this format where it's Skype or not?
Yes.
Skype? Yeah.
Yes.
Okay.
I think they're opening up for like on the water stuff.
Okay.
But not in the classroom.
Cool.
So the like on the water portions or like the in classroom portions of an on the water class, they're going to hold outside.
Oh, okay.
I think I've heard lots of variations of what's going to happen.
Sure.
So, yeah. But no, I'm planning for this class to be just like this. Next one, Coastal Nav 2.
Cool.
So we're keeping it this way.
And then after that is Celestial, or is that going to be next year?
Celestial is going to be next year. So this class goes right up until, or Coastal Nav 2 goes right up until Thanksgiving. And then we take the holidays off and we'll start Coastal Nav 1 again in January. And then I'm pretty sure this time in like May and June, we're going to do some of those workshops that we did, but you already took those.
Right.
And then the Celestial will be, I think it's summertime, like July.
July. Okay.
It's not posted on the website yet, is it?
No, it's not. That's kind of why I was asking what the general idea is.
I'm pretty sure it's during the summer. It should be being posted soon, though.
Okay.
Yeah, not posted yet. Okay.
So after Coastal Nav 2, the next one that you'd be teaching would be Celestial next summer.
Correct.
Okay.
Correct.
Cool. Good to know.
I'm teaching radar starting this week.
Remotely?
Yes, but it's through the it's a credit course.
Okay.
So you have to be enrolled in OCC.
Oh.
So it's like they do a first session and second session of the college semester. And so the second 8 weeks, I'm starting next week teaching that radar class.
Okay.
I don't know if it's too late to enroll. I don't know really how to enroll, but yeah, you're supposed to be a student with OCC.
Okay, no problem. That's actually kind of a shame because we just won a contract with the Navy to do a augmented reality headset that takes in radar and does real-time navigation.
Yeah.
So that would have been very fortuitous.
Yes. Well, you should check it out. I don't think it's impossible to get in.
Good looking.
I know.
So like over the top, good looking.
Exactly.
But yeah, give it a shot. I don't know how you get into it. I'm hopefully gonna get I asked to put it on the schedule this year, but they said a radar class for this audience, right? The just the local community.
Right.
But it's not on the schedule because we don't have a solid date of when the radar lab is going to be up and running, because it's at OCC's campus right now, but they're moving it down to the waterfront into the new building. So even the class that I'm teaching this week, we can't use the simulators or anything. It's just theory, my little videos and things.
Got it.
But yeah.
You know, if it's the same, I could probably see if I can radar telemetry stuff that's for simulators you could do on your home computer.
Yeah.
Maybe. I don't know. I'd have to look into what I'm allowed to do.
Yeah. It's cool. How's everybody doing?
Good. Okay.
Right.
How about yourself? How are you doing?
I'm doing good.
Good.
It's been a good week so far.
Just going by too quickly.
I'm going out to Anzo Borrego tomorrow. There's no moon, so the stars gazing is supposed to be going on pretty good. So I'm excited about it. All right. Well, while we're waiting for a couple more people to join in, this week, right now, is our last day of new information. It's our last day of kind of new instruction for Coastal Nav 1. So next week is kind of that the final cruise or the final assignment where it kind of reviews everything that we've done. Now it's already posted on the Google Classroom. The video tutorial is also posted as well. But as far as class goes, I'm going to be here and logged on, but I don't have any new information. So I'll just kind of be available for questions if you want to work the final here, you know, Wednesday night during class, or you could do it before and just check in with some questions, or you could watch the videos, or I could go over a new topic. Does anybody have a topic that they'd like me to cover or give a little PowerPoint on besides tides and currents and set and drift or GPS? We're going to be going over those topics in Coastal Nav 2. Any ideas? Think about it. Shoot me an email or a text or something if you come up with something. But as far as PowerPoint and things concerned, I don't have new information next week. It's just the final plot, which everything's posted. There's the video tutorial, so you could skip ahead. You know, you don't have to like wait for me to get to that problem. You could like skip ahead to number 5 or whatever, if that's one that you're stuck on. So I don't know. I think it's a little bit easier to look at the video because you can skip ahead. But again, I'll be online. You could just check in and say, hey, or you can do the video or whatever. I'll be here and available to answer your questions. So that's the plan for the rest of this class. For Coastal Nav 2, those of you who are interested, we're not having a break this time. It's going right in the following week. We'll start Coastal Nav 2 same time. It's a new Zoom link and a new Google Classroom, but I'll be emailing those out to everybody the week before. And if you are in Coastal Nav 2, I would suggest getting radar plotting sheets. I have a PDF printout of one on a piece of paper, but I wanted to show you an example. They're a lot easier if you have the actual paper. They look like that. And that's how we practice our set and drift kind of thing. They're available on Amazon. They're also available at the store down on the waterfront, the OCC store. I think they're like 5-10 cents or something. So if you just want to get like 3 or 4, that's great. If you buy it on Amazon, it comes in like 100 pack. So just throwing that out there. And if you don't want to do it, I do have it on the PDF. You could just print it out on a piece of paper. It's just a little bit condensed. Anyways, that is my my kind of announcements for the day. So today we are going to go into 2 new types of positions, our running fix and our bow and beam, and then we're going to plot all of those fixes, and we're going to be working on the Long Beach San Pedro channel chart. So no training chart today, just the San Pedro channel one. Any questions so far? We ready to get started? All right. Oh, if you are going to take CoNav 2, I would sign up for it sooner rather than later. So if I send the links to things, you'll be included in that email. So you sign up through OCC. Okay. Let's get started. Okay, so last week we talked about getting a fix, so using 2 or more LOPs and having them all cross in a single point, which kind of doesn't really happen. It's more of a triangle, but we try to get that single point, and that is your basic visual fix. Now we're going to have 2 more types of fixes, our bow and beam, and that's going to kind of be like a shorthand quick one. And then our running fix is if our LOPs are at different times. And then our last topic is about danger bearings. So that's just a little quick thing to keep in mind as you are navigating. So we're going to get into the PowerPoint and kind of going after each topic. We're going to go to the chart and plot for assignment 13, I'm pretty sure. Yes, assignment 13. We have our practice bow and beam and then our practice running fix. So we can have that ready, but let's get started. All right, so our bow and beam fix really capitalizes, I guess, on basic geometry, on our isosceles right triangle. So the principle of having a triangle that's a right triangle, meaning 90 degrees at one angle, and then the other 2 angles are equal. That would make the other 2 angles 45 degrees. And if those angles are equal, then those lengths of the sides of the triangle are equal. So again, if these 2 angles are equal in the triangle, then the length from B to C and from A to C are the same as well. So if the angles are the same, the lengths of the triangle are the same. So let's look at it. If A is a lighthouse and we are at B and we are traveling, so we see the lighthouse, and I'm going to call it broad. In this case, it'd be broad to starboard or broad on the bow. So if you are steering along and you know what's dead ahead of you, you could see what's at the beam of you, and you could have your best navigator's guess of what's broad or at 45 degrees relative. So at 45 degrees off the bow, you see the lighthouse. You mark the time, well, not yet, but the distance traveled from when you saw it broad on your bow to when you see it a beam, making that 90, right? Making that 90 right there. Then you could say the distance run, the distance that you traveled from when you first saw it brought on the bow to when you saw it on the beam, is equal to your distance off. So we're going to use that distance off as our LOP. So we can have an LOP of, yes, it's on the beam, and what is my distance off, to get 2 LOPs and get that real quick fix. So let's look at an example of this. Nope. This is the same thing. Oh, okay. So how we find our distance run is by noting the times. So I saw it, you know, at noon, and then I saw it at 12:30. So if I know the estimated speed that I'm going, we're making a lot of assumptions here, right? We're assuming that this is exactly 45. We're assuming our course, we're assuming our speed. So there are a lot of assumptions, but it is a little bit better than a dead reckoning position. So we are assuming we're making our speed. We can calculate using 60D Street the distance we traveled in that allotted time, and that will be equal to the distance off. And we're going to use that distance off as an LOP. So let's see our steps. Do I have, no. Okay, so step number 1 is to note the time when it's broad on the bow. So if you do have somehow the structures on board, maybe you have little winches or just stanchions or something on board that kind of measures from your helm where a 45 would be if you had those lined up, or just generally 45 degrees, you know, to starboard or to port. This works on either side, to note that time. The more accurate you are on that time, the more accurate this fix is going to be. But again, it's just kind of that quick fix, so don't stress too much about the super accuracy of it. Second step is we're going to note when it's a beam of us. So finding something that's a beam of us is a little bit easier. Usually, you know, maybe the transverse or the aft portion of like the house, or maybe, you know, 2 winches again, or something is pretty perpendicular to the keel that you could find, you know, line something up that is exactly a beam of you. And again, that a beam fix, that is going to be changing rapidly, right? Because things that are a beam of you change quickly than things that are ahead or behind you. So we're going to note the time that it's on the bow. We're going to note the time that it's on the beam. And then we use our 60D Street to calculate distance run, distance off. Again, use the structures on your boat to be as accurate as possible. And these relative degrees here, you can just say, you know, on the bow, they call it the bow angle, or that broad on the bow, but technically speaking, it's that 45 degrees relative or 315 degrees relative, meaning it's 315 degrees clockwise from your bow. So that 315 would just be 45 degrees to port versus 45 degrees to starboard, or your 90 and 270. Okay, any questions so far? Is that kind of making sense for us? Cool.
So it seems like you could introduce a pretty big error if your speed was not correctly known then, right?
Yes. So we are, you know, taking some assumptions into account here. So we're trying to be as accurate as possible, but it is a better fix than just a purely calculated speed, distance, time, course calculation, a DR.
Okay.
When you say 315 and 270 relative, that's if you were staring down a compass.
So relative is relative to your bow.
Okay. Good.
So you could be headed any direction, and the relative means that 0 is where your bow is pointed, not where north is, or magnetic north, or true north.
Okay.
Okay.
So I'm trying to figure out how far I am from the lighthouse.
Yes, and we're going to use that as a position. So we're going to
And
do
I'm
it
trying to find how far I am from it.
correct.
Okay.
Okay, so here's an example. We are on course 000, speed 10 knots. So we're headed due north, speed 10 knots. We see the lighthouse on the bow at 6 o'clock. Then we see the lighthouse on the beam at 6:30. So we have 30 minutes that passed at 10 knots. So we use our 60D street, and we see that 5 nautical miles. We've traveled 5 nautical miles in this time frame. So now I can deduct from this that I'm 5 nautical miles away from that light that I am observing. So then when I plot this, okay,
So you knew your speed from 6 to 6:30. That's known.
yes,
Okay.
I knew what my course and my speed was.
Okay.
So here I used that RST, that's relative ship's heading and will equal true. So if it is 90 degrees to port, we're saying that something abeam to us is going to be at that 90 or that 270 plus our heading. In this case, it was 000, so it's pretty simple, but I will show you in when we do it on the chart here in a moment, how you can do it in a different way. Okay, so on the chart, down here is our chart. Let me move this real quick. Okay, so down here is our chart. We have the
Hey,
light.
Bree?
Now I want to plot a position.
Am I on?
Yes?
I'm off. Well, so R is relative and S is ship's heading, but that ship's heading is a true course, right?
Correct. And this would equal our true bearing. Okay, so we have the light on the chart, and now I want to plot a position using this information that's given to me. So I know that I'm a beam of this, and my heading is 090. So I'm going to plot a line. If I am a beam of this light and my heading is 090, I'm somewhere along this line. Infinite possibilities, right? It's an LOP. If I'm a beam of it at 6:30, I am somewhere along this line at 6:30. Don't know exactly where I am. But because I noted where I was when it was brought on the bow, I have a distance off. So I have that 5 nautical miles off of the light. So now I can use that, measure 5 nautical miles, swing my arc, or just make it a point, and say that is my 6:30 position. So now I have a rough 6:30 position that has a little bit more data than just a DR. Oops. Okay, did that clear things up a little bit more? Maybe a little bit. Okay. Okay, so now we're going to do it on the chart together. So let's bring out our, I have it right here for us. Move this away. Share.
Bree, can I ask a question?
Yes.
Maybe I missed it when I was making some notes. Where did the 90 degrees come from?
So that was perpendicular to our heading. That was our beam
Okay,
bearing. So if we are headed north and we found something on the beam, the bearing of that object to the beam
is
is
90 degrees.
090.
Understand. So you just make that assumption that it's 90 degrees.
Yes.
Okay.
So
Thank
we're
you.
assuming that it's at a 45, and then we're assuming that it's at a 90.
Thank you very much.
Okay, so I'm hoping this covers as much as I can. Let's get okay. Okay, so we're going to do assignment 13. Okay, so assignment 13, let me get this here too. I can draw. Has a 12 o'clock position, and then it says we are on course 115 at 7.2 knots. So let's plot that first. I need to erase this a little bit. Okay. So it's supposed to be a little bit of an easy position because it's already on this latitude line. And then our longitude was 26.1. 26.1. So from our latitude, so this is our position at 12 o'clock. And then I have a course of, excuse me, a course of 0 or 115. Okay, so if you're watching, I have on my triangle pivot point on the dark line and 115 on the dark line. And I was pivoting against that point. Draw my line. So I have a course of 115 at a speed of 7.2 knots. So in this case, I am starting with a known position, but you don't have to start with a known position. This is just kind of, I don't know, showing you how this 45-45 works. Okay, you guys with me so far? Okay. Gonna wait for another minute. If you're using the parallel rulers or triangle, you might have to, this 115, shift it down a bit or try to get it from the one up here, but that's where my computer is. Okay, so I'm going to move on here. It tells us at 12:16 we see long point. So here's long point at 45 degrees relative, and then at 12:46 we are a beam of it using 60D Street. So we're basically plotting our fix now. So the first thing I'm going to do when I have a bow and beam problem, and this is another reason I like the triangle, is we already have our heading line in here. So I'm going to use that perpendicular line. So that perpendicular line is lined up on the track line or the course line of where my boat is pointing. And as I'm traveling down this line, anything that is along here would be on my beam, right? As I'm traveling down, there's my boat. I'm traveling down, anything along these sides is the beam. So if I see that at 12:46, long point is on the beam, I can line up this long point and be perpendicular to my triangle. And I can say, this is my LOP. I am somewhere along this line at 12:46.
So at 90 degrees off your starboard side.
That was 90 degrees off my starboard side. So I did that shorthanded by using that 90 degrees. You could also do that with a roll plotter. There's a 90 degree on there too. You can't really do it with the parallel index, but if you're using parallel rulers, you could use that R plus S equals T method. You had a relative, it was bearing 90 degrees relative. Your heading was 115. So R plus S gives you the true bearing. So your true bearing of it would be, I have to calculate that. Gives you 205. So then you could go find your 205. Parallel up to long point and draw on your line. So if you're using the triangles or you're using the parallel rulers, you do need to do that R plus S equals T, converting that relative bearing into a true bearing. So you could plot it on your chart. If you're using the triangle or roll plotter, it has that 90 degree on there. So even if you were, over here or something, you're at 90 degrees, you're still drawing your line. Okay. So we have one LOP, now we need a second LOP. The other information that they gave us was 12:16. We had, I'm gonna call it our bow bearing, right? It was 45 degrees relative. And then at 12:46, it was on the beam. So now I'm gonna use that 60D Street to calculate my distance run, because that will equal my distance off. So let's do distance run. We need D, S, and T. 12:46 minus 12:16 gives us 30 minutes. Yeah, I was like, is that right? 30 minutes, so our time is 30. Our speed was given to us at 7.2. We're looking for our distance. So let's do the magic circle. D, D, S, T. This is our question. Speed 7.2, time 30. So 7.2 times 30 divided by 60, D equals 3.6 nautical miles. So we have a distance run between these two times of 3.6 nautical miles. Because of our, as we're traveling down here, we have this 45-45 angle. That distance run is equal to the distance off. So now we can measure 3.6 miles. 1, 2, 3. 3.6. So I have 3.6 miles from Long Point. I swing my arc, and now my I have my LOP and a distance off. So where those two meet is my 1246 position.
So you didn't know your position at 1216.
No, I didn't even write it down.
Okay.
It was in the past. I'm going to put the latest information on the chart.
Gotcha.
But by doing this, you were able to come up with your distance off Long Point. You didn't
Correct.
have a way to find it. It's kind of cool.
Yeah. So again, you know, if you mark the time when it's a little bit, you know, less than 45 or more than 45 off the bow, then your distance off is going to be, you know, further away or closer. So the more accurate you can be, the more accurate your answer is. But again, this is just a very quick and dirty way to do it. I guess is what I'm saying, that it's better than a DR, and essentially you don't really need any tools. You're just like, yep, that's broad on the bow. Yep, that's on the beam. I got to fix. So if you don't have a handheld compass, or you're not taking bearings one way or the other, you can just do a quick little fix that way. So yeah, you're making lots of assumptions along the way, but it is just cool to bring that geometry and that those principles into the navigation part of it, I think. So, okay. Any questions on the bow and beam?
Yeah, hello, Bree.
Yes.
I'm like way off when I do this. I got like a 27.6 on my latitude.
On your latitude.
Yeah, you have 27.15, so I'm like off.
Oh, I didn't get my latitude. Let's see. Roughly, is it off 26, 27? I got 20. I got 27.6. Yep, that's it. That's an error.
Oh, okay. All right.
That should be 27.65. I will.
Okay.
Yep. Thank you.
Well, no, thank you. I was going, what am I doing wrong?
Nope, you were right.
Thank you.
Thinking I've edited these and then something happens. Okay.
Hey, Bree,
Yes.
can you explain again the 205 degrees?
Yes.
I want to hear that one more time and understand how we use that. What was the, because I never saw the 205 used anywhere in the calculation, so I'm just curious how you did that again and what it was for.
Yep. Let me get my screen back. My mouse isn't working. Here we go. Okay. So for relative, this is a large boat. Let me erase that. So we are headed at 115 degrees. So from that 115 is basically 115 degrees from north, right? True north, 0, or true north. That was our heading. Then we have long point down here. And this was bearing 45 degrees. Oh, wait, we are saying it's the beam now, aren't we? Cancel that. It's on our beam. Here's long point. So here's long point. And we are saying that it is 90 degrees on the beam. So from our heading to the light is 90 degrees. So then if I want to draw this on a chart, I have to find that 90 degrees is a relative bearing. So I would need to find what the true bearing is on the chart. So to find true, I'm going from north all the way around to that line. So that's my ship's heading plus my relative is going to give me the whole true. So I have R plus S equals T. Now how I plotted that would be when you have the long point here on the chart, and I don't have that triangle, I've calculated that 205, so I could go from my compass rose down here, here's 205, and just draw in an LOP at 205, and then draw in my distance off to say this is where I am. So we're using that 205 if we don't have a heading line or a heading tracker. If we don't already have plotted, this was my course and this was my speed, that I can just quickly make a 90 from my heading line using your triangle or a roll plotter. Does that make sense?
It does. That helps so much. Thank you for,
Why is that?
for doing that. So that's a quicker way to calculate the true bearing of the lighthouse at Long Point, or the object at Long Point, and a way to test it if we had a hand bearing compass and did the deviation and the magnetic variance, it should match.
Yes. Yes.
Okay, cool. I got it.
Yeah.
Thank you for going through that again.
Yep. Okay. So okay. We will be doing another bow and beam problem in our chart plot tonight, but now we're going to move to a running fix. Any questions on the bow and beam before we move to running fix? We will be doing more examples of them, I promise. Okay. The running fix. So the running fix is used a lot. And the basic definition is that it's two lines of position observed at different times. So last week we were getting our fixes by having these simultaneous LOPs. We were getting ranges and bearings and multiple visual bearings all at the same time. Now, if we can't get it at the same time for one reason or another, we can still use that past information and plot a running fix. So the running fix, where you just have an R next to it, means that your LOs, Ps weren't observed at the same time. Now, basically, how you're going to do this is by advancing, which is basically just paralleling, moving your earlier LOP to the time of the latest information. So we're always going to plot what the latest information we have. So like we didn't plot our 45-degree line because the latest information was that 90-degree line. So we're going to plot that 90 or the latest information, and then we're going to advance the later one to the earlier one, and now we have two LOPs that cross. So we are assuming our speed and direction, and I'm going to say 90% of the time you're going to be advancing. The only reason you would be retarding, meaning putting your line to a later time, is if you wanted to calculate your, say, your noon fix or something. You wanted to know where you were going to be at noon so you could do easier ETAs along the way, and you didn't actually get a noon position. You can just retard your lines along the way. Most commonly, it's used in celestial navigation when you're advancing and retarding all of your sun or star lines into the same time. But again, 90% of the time, we're going to be moving it forward in this example. But I just wanted to caveat that sometimes you do it the other way. Okay, so what are our steps to do this? We want to have plotted our DR track line. So whether that's a known position way later on and we had our track line, we want to have that plotted so we can work from that. Like on our bow and beam, when we had that track line plotted, it was a lot easier to work off of it because we already had that one plotted. So I like to have that plotted. We draw the first LOP, and then we calculate the distance traveled to the time of the second LOP. So again, we use that 60 D street. If we got this LOP and our time traveled is, or our distance traveled in this amount of time is 1.5 miles, we're basically paralleling that old LOP 1.5 miles along our track line and plotting it again. So I know this is a lot of words right here, but I promise it will make more sense when we do it together. So we mark where the first LOP crosses the track line. And again, we're using that track line as a reference point. So that is where we're going to be drawing our old LOP again. You parallel it up, create the new LOP, plot your second LOP at the current time, and then where the two cross is your running fix. Now, I think I make it, nope, I don't. We want to remember that this, these two LOPs that we are creating, wherever they cross is our running fix position. It will most likely create a triangle with our track line, but that track line is not an LOP. So we are not calling it a triangle or a cocked hat. Just where those two LOPs meet, that's where our running fix is. So let's look at some examples. So this is from the book. So we have plotted here our track line. We are on course 012 at a speed of 12 knots. So this here is our track line, and we have DR positions plotted. So at 1500, I observed Lighthouse E, plotted that position. So I'm somewhere along that line. And then at 1520, I'm going to advance line. So this one isn't a quite a running fix because I didn't observe it again at 1520, but this is just showing you how you advance that line of position. So if we were traveling at 12 knots in 20 minutes, we traveled 4 miles. You're just moving it 4 miles along that track line and plotting the line again. So that's what I mean by advancing the line of position. Okay. Now, this is what it would look like if we had that running fix. So again, we have 010, 12 knots. We plotted a 1500 line from light E, and then we plotted a bearing to stack F at, what time was that? 1520. So if this was at 1500 and this was at 1520, I want to advance my 1500 to 1520 so I can get where they cross. So again, that was 1520 or 1540. So the latest time I observed stack F. I'm somewhere along this line for stack F. I don't know where I am exactly, but I'm going to use the old information of my 1500 LOP, advanced 4 miles along my track line, and paralleled again. Now where those two cross is my running fix. And then I can plot my track line again. Okay, let's look at another one. Okay, in this one, sorry, I'm going back to it. We used 2 different aids to navigation, or points that we got a bearing from. The other really cool thing with the running fix is that we only need 1 aid to navigation. So say there's nothing else you can see, it's super foggy, or there's no other aids to navigation around, you just have that one. You can use it different times to get a fix. So as we were saying, we want, our angles of our line, 90 degrees if it's 2, 60 to 30 degrees if it's 3. We can use time to change the bearing of something to get a better position. So we only have 1 aid to navigation that we're getting our lines off of. So let's explain this picture. We have our course, 018, 12 knots. That's our track line. At 1430, we have an LOP to light G. And then at 1452, we have another LOP to light 2. It's not quite on the beam, but pretty close. Now I want to advance my older line to my newer line by so I can get a new fix. Now how I do that is the distance traveled, or the distance I would travel from 1530 or 1430 to 1452, whatever distance that is going to be this distance right here, from where that first LOP intersects my line of my track line to where my however distance traveled, put it on the track line, and then parallel my line again. So that's going to be our easiest way to draw this running fix. I'm going to add in something right here. I know this is a lot of information right now, but we kind of talked a little bit about estimated positions. So an estimated position is if we just have 1 LOP. So in this case, at 1430, we only got one LOP. So our estimated position is going to be the closest position along this LOP to my DR. So this is my 1430 DR. So my closest position would be kind of about right there, which is basically how you do this, is a 90 degrees to your track line. So that's why I'm saying right about here. And I could show you this on the chart, but right about here would be my estimated position for 1430. So it's just one LOP and your DR, wherever your DR is closest point on your LOP is your estimated position. If we have two LOPs at different times, then we can get a running fix. So we're kind of building on one another. You can still get a running fix with, it doesn't have to be a lot or a bearing line. You can still do it with a distance. So in this case, we had a range at 1430. And then we're going to advance, basically we're advancing this aid to navigation to whatever distance we would have traveled between 1440 and 1508. So whatever distance that was, we're advancing it, and then we're creating another LOP, the same distance off from that buoy. And then if you get another LOP from the light, wherever those two cross, that's your running fix. So this concept of moving the aid to navigation in the course or in the direction that you are headed at the same speed is basically what you're doing along your track line. But I'm going to show you that on the whiteboard a little bit. Okay. Stop that share. So how confused are we? Super confused? Somewhat confused?
Mildly.
Mildly confused? Okay.
I get the concept. I'm understanding the idea.
Okay.
You know,
Good. That's a good step.
those are equal angles on each side of those connections. They mirror each other. I get it.
So let's do a problem. Back to assignment 13.
I'm just thinking about getting the best GPS system I can.
That's also a good method too.
No, GPS works off of dead reckoning, just so you know.
Okay, so we are up towards data points. So I need to move my camera here. Hold on. Shoot. Okay. Okay. Let's share my screen. Well, it's Newport. That's the wrong harbor. Okay. Okay. Kind of all over the place today. So for our running fix, we are in Newport. We have an 8 o'clock. At 8 o'clock, you plot a position. You're steaming on a course, so we can plot a our position with our track line. And then we're going to have 2 LOPs at different times. So our first step is to plot the position and plot the track line. So I've made it easy for us in this practice. Our position is right where those 2 latitude and longitude meet. So our latitude was 33 degrees 30 north and 117.50 west, and that was at 8 o'clock. So then I want to plot my course line. Let's do the difference. Let's mix it up here. Okay. So if I'm using a roll plotter, we have a compass pretty close. So our course was 143. I can't find 143. Oh, there it is. 42. Okay. There is my course of 143 at a speed of 10 knots. I'm just going to check it on this. Yeah, that's 143. Okay. Okay, so we have our, gosh, my chart is wobbly today. We have our track line, and then it told us at 8:25, let's get a better marker. We were able to see the buoy 2SJR at 080 degrees true. And then at 8:43, we saw 2SJR bearing 030. Plot our running fix. Okay. So we have 2 LOPs at different times. So the buoy in question is this buoy right here, kind of at the end of Dana Point. So that's our SJR buoy. And I'm going to plot the old one first. I know I was saying you don't have to, but I changed my mind, you do. So I'm going to plot that at 080 first. Okay, so here's my SJR buoy, and I'm going to find 080. Can it reach? It can. Okay, so here's 080 and the focal point, and I'm in line. So I know I'm somewhere along this line at 0825.
And how would you do that with the roll plotter? Just run.
I would find 080. I'm gonna have to do it this way. 080 on the compass rose here,
Okay.
and then just roll it down till it hits my buoy, and then draw in my 080.
Okay. Just like you're same as plotting the original course.
Yep. I'll do my next one on that too. Okay, so that's where I was at 080. Now my next LOP was 030. So I'm going to find 030. Make it higher. Here's my 030. Parallel it down. So I'm somewhere along this line at 0843. Now I somehow want to make these two lines cross. Now how do we do that? We need to advance this line down to our new time. So this was at 8:25 and this was at 8:43. So let's do 8:43 minus 8:25. That gives us 18 minutes. So now we have our D is what we're looking for. Speed is 10 knots. And our time is 18 minutes. So my distance traveled in this amount of time was 3 nautical miles. Everyone see where I got that? Okay. So now, oh, here they are. I'm going to find 3 nautical miles on my dividers. Here we are, 3 nautical miles. And now I'm advancing it along my track line. So it was here, now I want to advance it 3 nautical miles. So I'm seeing where that 3 nautical miles will be. Right there. So that's not a position or anything. That's just where I'm going to advance my line to. So here, I'll use my roll plotter again. You can use your triangle. I'll show you how to do it on triangle in a second. I'm paralleling it from my old LOP. Just lining it up there. And then I'm going to parallel it down to where it meets this new point that I just made. And now I can label this line 0825 to 0843. So now both of these LOPs here have the 843. And now I can say that this right here where they cross, that is my 843 R fix. So again, we did come up with a little triangle here, but this is not an LOP. That's just a track line.
You rolled the plotter down from your 825, right, to your 843 bearing at 30 degrees?
Correct. It was 3 nautical miles, right?
Okay, yes.
So from where
Okay, so that's how you got your fix at 843.
That's how I got this fix. Was I paralleled this line down.
Okay.
So another way to think about it, some people like this. Oh, hold on a sec. Before I do that, I'll show you how to do it on the triangles. Line it up, and to parallel something, you just need a straight edge. You could use another triangle or just a ruler if you want. And then you could parallel it down. So just like that. So in this case, I'm going to parallel I'm just drawing this out. You guys don't have to do this.
And how'd you get the point where you're making the new line?
So that was our distance traveled. So
But in what direction? On the course line?
On the course line. So basically what we're doing is the distance I've traveled is 3 nautical miles. So I'm basically moving that aid to navigation. I'm basically like DRing that aid to navigation, my speed and course, and then plotting it again. So I'm kind of made this parallelogram, if you will. Moved this, made this my buoy, and then replotted that line. Now the quicker way to do that is by just marking it on your already plotted track line. So that's why I try to teach it that way. So you don't have to plot so many lines. But that's basically what you're doing in a running fix, is moving that, whatever you got, that aid to navigation, you're DRing it to your time of the later one, which was our 8:43. And then you're creating that, that LOP again. Does that make sense? Did that help at all?
It did, thank you.
Okay. Okay, another thing I wanted to show you. Do I want to show it to you? Hold on. No, I'm going to keep it simple. I'm going to try to keep it simple for you guys. Yeah. Okay.
We've gone to the right off of our original course.
Correct.
Just a little.
We are to the right of our original course.
Right.
Oh yeah, that's part of the answer. Yeah. Okay. How you guys doing so far? Kind of coming together?
Yeah.
No problem.
All right. Well, let's take a quick break here. Let's come back at 10 till. Let's come back at 7:50, and we'll do assignment 14. So that's on the same chart. You don't have to bring out a new chart, but we'll do assignment 14 together. But that is our new information, and then we're gonna start doing the homework. All right, and again, if you guys come up with any topics that you want me to talk about next week over the break, think about it. I'd love to hear them. Again, next week, so for those of you as latecomers here, next week I don't have any new information. I will be on Zoom and available, but all it is the final assignment, and you can do the final assignment, next week at 6:30, or do it sometime during the middle of the week. The video of it is recorded and posted, so I guess I find it easier, instead of waiting for me to do something, you could just skip ahead to number 5 or whatever it is that you want me to show you. Or I'll be available. I'll be on Zoom with the charts and everything next week, so I can show you in person as well. But no new information next week. So if you guys can think of a topic, I'd be happy to talk about a topic. Or I'll just hang out. You could check in and do your thing. And then week after that is CoNav 2, if anybody is interested in that. So yeah, let's take a 10-minute break. I'll be back.
Hey, Bree, do you have an idea of what kind of topics would be available? As in which ones, I don't know, what type of topics are you talking about there?
Really anything.
Election.
No, really anything in the maritime industry.
That's what I meant.
We got, I don't know, I could just show you pictures and see stories or just hang out. I don't really have a plan on this distance learning style last day.
Okay.
Agree. What would Coastal Navigation 2 encompass? Where would we go from here?
CoNav 2 is all about set and drift and tides and current. So we're going to learn how to calculate tides and current by the book, or just get it from an app or whatever we have, and then apply it to how we're going to steer or how we get set along our track line. And then the last day of CoNav 2, I do a little lecture on GPS.
Cool.
So a little bit of electronic navigation.
Excellent. It sounds important.
Yep. So if you guys want to do that, sign up. The sooner the better.
Okay.
And if you are taking the class, I recommend getting radar plotting sheets.
Okay.
They're sold in the store down at OCC, or you could get them on Amazon. They're like 10 cents or something in the store, or you can get like the pack of 100 on Amazon. Yeah.
Excellent. Thank you.
We're going through the homework after we return from the break here.
Yes, we're going to do assignment 14 together.
Okay.
So we'll do step-by-step assignment 14.
Bree, I wanted to take a little more time after this class to work through more of this stuff. Do you have another Coastal Nav 2 scheduled yet? Or do you know when that might be?
Yes. So starting in January, I think it's like the second Wednesday in January, we do Coastal Nav 1 again.
Okay.
And then directly following that will be Coastal Nav 2.
So March probably sometime.
So yeah.
Okay.
February,
Great.
March, somewhere like that.
Thanks.
Yeah. All right. I'll be back. How you guys doing? Is everyone back?
Back.
All right. So we are getting ready to do our assignment 14, the advanced cruise along the California coast. We're basically going from Newport to Dana Point, so not too far. Sorry, guys. Okay, sorry. Let's see. Share the screen. Okay. We'll try it that way. Okay, so here's our Newport. Here's Dana Point. Kind of. Maybe I need to focus it. That's a little better. Okay, so at the beginning of this, we actually throw in a little chart correction. So throw back to week number 1, and we say, as you prepare for your voyage, you review the local notice to mariner, and you see that they're reporting a new lighthouse. Now, remember, this is a made-up problem. This is all fiction, made up. There is no actual lighthouse there, but we're going to plot it on our chart anyways. That they told us there's a new lighthouse between Laguna Beach and Dana Point named Two Rock Point, and it has light characteristics and it has latitude and longitude. So our first step is to plot that latitude and longitude and add in that light. So we are going back to our latitude and longitude skills. Let me try to hanging off my table here. So we have a latitude of 32.9. So here's 31, 32.9. And I have a longitude of 48.3. So it is that we have a little point called Two Rock Point. So right there is our lighthouse. And we could write in, goes my pencil, flashing 10 seconds. So we added a new aid to navigation right there. Okay, so that was step number 1, is to plot our new aid to navigation. And then it tells us we plan to leave Newport Buoy, so that's our NWP buoy, at 8 o'clock and cruise on a course of 120 per standard compass towards Dana Point at a speed of 5.2. So that course that they gave us is in, let's go this way, compass. So we need to do can, dead, min, vote twice at elections. So we have 120 degrees PSC, and we need to convert that to true so I can plot my track line. Now I need to get my deviation table. So if I have a compass heading, again, it's our heading, this is my heading. If I have a compass heading of 120, that would give me a deviation of 4 east. I'm going down, I'm adding east. So I have a magnetic of 124. Variation is on the compass rose. We've been using it for a while here, 12 east. We're going to add that, it's east. We're adding east. So we have 136 degrees true as the track line I can mark on the chart. So let's plot that 136 true. I'm going to put my pencil on our departure point, and I am going to find 136. So here's 135. One, 3, 6. So there is my track line.
You're
And
tracking 136, not 120 towards Dana Point.
That was 120 per standard compass.
Oh, gotcha. Okay.
So we just converted that 120 to
true.
136, true.
Okay. From that buoy, from the Dana Point
From the-
NWP.
From the Newport, yeah.
Okay.
136. And our speed is 5.2. So we have our 136 line, and then it asked us what is our DR position and time that we are going to be abeam of this 2-rock point. So quick on the triangle, we have that little abeam line, right? So we can just put our point on the 2-rock light, line up our line, and this is going to be our DR position. And we need to figure out what time that's going to be. If you can do that on this one. If you didn't have the roll plotters and you had the parallel, you would have to subtract 90 degrees from our heading, right? So we would have to have our 136 minus 90, and that gives us, what does that give us? 0.46. That I would have to plot 0.46 using my parallel and then bring it up, and I could draw in my line that way. So we have our DR position. So we need to get what our DR position is. Let's see. Here. Two, 1, 2, 2.1, north, 33 degrees, 1 north. This is 59.2, 59.2, 59.3 west. And to figure out the time, this was at 8, so I need to see what my distance is to figure out my ETA. That this so you guys can see. So 800. This is 90 degrees. I need to measure.
Isn't that 49.2, not 59.2?
You're right. Yes. 49.2. I have a distance of 4.1. So now I need to figure out what time it was. We use our 60D straight. We are looking for time, so we have 60 times 4.1 divided by 5.2 gives us time. What is our time? Anybody get a time?
46.
8:47.
47 minutes? Go with it. Yep, so 47 minutes, if that's 8, we would have a DR of 8:47. So if we knew someone that was hanging out in between Laguna Beach over there, to Rock Point, we could say we'd be there about 8:47. All right.
If we know we're going at a course rate of, what do we say, 5.2?
Mm-hmm.
So aren't we able to plot a point on that course line where we are going to be at in an hour?
Correct.
Okay. So it seems like you can almost solve for, that, I guess, point that's a beam, if it's 90 degrees, we could go 90 degrees off that point and then use the information there to actually find almost solving for the unknown position.
Yes, you can solve it finding, that way too, finding that distance going back, or you could just, eyeball it and say, I'm about, 25% from my 9 o'clock. I'll probably be there about 8:45.
Right.
So you could work it anyway. Okay. So that is our practicing Notice Mariners in a DR. So now we're going to move to our second section here. 2 LOPs. So at 8:38, so I'm 8:38, I'm assuming I'm going to be, somewhere in this region. At 8:38, we take a fix from Newport Buoy, which is behind us, and our 2 Rock Point. So we have 2 bearings. They're both true, so we don't have to convert. So we can just draw those in. At 8:38. So let's find, from our Newport buoy, it was bearing 313. 313. And from our fictional point, we were bearing 065. So here would be my 838. Gonna make that a little bit bigger for us. Let's use new color here. So we had, so we have an actual location, an actual fix at 838 by plotting our two LOPs. And now they ask us a couple questions. What was our actual course over ground? What was our actual speed over ground? What is our actual position? And then are we on our original track line or not? So again, that's kind of a bundle of questions there. So we are not on our original track line, right? We are to the left, we are drifting closer to shore. So you always want to be aware if you are drifting closer towards a danger or further away from a danger. Oh, I didn't go over danger bearings. Remind me to do that at the end. I'm writing it down. Hold on. Okay. Got a sticky note. Okay. So we are to the left of track. We are drifting closer to shore, so we just want to be aware of that and maybe take aggressive action to correct our course so we can be drifting away from shore or away from a danger. So we can get our position, lat long, and then it asks us what was our actual course over ground and our actual speed over ground. So if this was our last position at 8 and this was our position at 838, our boat actually traveled over this line. So this is the line. I'll make another color. This is the line that I am measuring for both my course over ground and my speed over ground, also known as course made good or speed made good. They're the same things, just some people abbreviate it differently. So we need to measure that line. We're just going to use our plotting tools to measure that line. And we actually already measured that line because we drew it in there. So we can get it that way. But our course made good was, what do I have here? One, 3, 3. My course made good was 133 degrees true, which is true. Basically a reciprocal of that bearing, right? The bearing was the bearing here was 313, and because that was exactly astern of us, we could kind of see that our course line has drifted, and we have a true course of 133, where we wanted our original true course to be 136 degrees true. That's what we thought it would be. Okay, and then for speed made good, I need to measure this distance. And on that distance, I got 3.8. And then we are going to go back to our 60 D Street. Erase this 60 D Street so it's not confusing. We have our distance, we have our time, we're looking for speed. So we're looking for speed. So we have 60 times distance over time equals speed. 60 times our distance of 3.8. And our time traveled was from 8 to 8:38. So 38. What was our speed? 6 knots. So we are traveling faster than our original, what we thought was 5.2, and we are drifting closer to shore. So we will need to adjust.
Bree,
Yes?
how would you have found that your course over ground with a triangle? What would
Yes.
the points you would have started with?
So I would, you have your starting point and your end point. So you want to line up the black line on that line, and then the focal point on the vertical line.
Got it. Okay, thanks. That's easier than I thought.
I have the light right here. It's kind of annoying. Is it too dark if I turned it off?
Seems
Maybe
okay.
that helps. Okay. So I know this is messy here, but any questions on that little section there? We follow along. I went a little fast, I guess. Right, so let me erase this. So our next section is practicing that running fix. So we're going to do a running fix. After plotting, the fog rolls in. After plotting our 838 fix, you decide to steer 140 degrees PSC at 5.2 knots, so you can move a little further away from shore. You're still concerned about your position, so at 8:56, you observe a bearing, and then we're going to use our old 838 bearing and advance it along. Okay. So our first step, the first thing they told us here was that we changed course. So after plotting, so at 8:38, we changed course to 140 degrees PSC. So whenever we change course, we need to replot our new track line and new DRs if we want, but we don't have to do that right now. But we need to draw in our new track line. So we need to change this. That pencil's not going to work. Can dead men vote twice at elections? My compass course was 140 degrees PSC. I need to convert it to true. $140 gives us 2 east. We're going to be adding that east, so we get 142. 12 east is our variation, so we're going to add that, and we get 451. 154 true. Yep. So from my 838 position right there, I'm going to erase my old stuff here. Just try to clean it up a bit. Okay. So we changed course to 154. So there is my new track line at 154. And now I am going to plot, let's see what they told me. They said we're still going the same speed, which we know because from our last one, we might be going a little bit faster, but we still think we're going 5.2. So let me draw this out in a larger form here. There it is. This is our course of 154 degrees true at 5.2. Okay. So there's our position at 838. We have a new course. We got a running fix here. They told us, so at our 838, we knew that our 2 rock point, okay, was bearing, what was it bearing? 065 degrees true. That was our old information, right? We had 065. Then it told us we're still concerned with our position. So at 856, with a little luck, you observe the South Laguna Hospital bearing 103 PSC. Remember, your heading is still 140. Plot a running fix. Okay, so we changed course and we got a bearing of the hospital. Now I need to plot this information so I can create a running fix. So my first step here is going to be converting that to true. So we have C, D, I never get one that works. C, D, M, V, T. Our variation for 4 degrees was, we just did it. What did we just do? 140, was it 4? No, it was 2 east. 2 east. So we add 103, no, 105. Variation was 12 east, so we add that, and we have a true of 117. Sorry, Was I off the chart there? Okay, so now we have our true bearing of 117 at 856. So let's plot that. 117 from the Laguna Beach Hospital. So here is our South Laguna Hospital. It's a little square, I think.
Hey, Bree, I think if the compass heading was 103, the deviation is 5.
So the compass heading was 140. The bearing was 103.
Ah, okay. I got you.
Yep.
Thank you.
Yep. Okay, so our hospital is going to be bearing 117. So I am somewhere along this line. So let me draw it on here. Something like that. And this is where we are at somewhere along this line at 856. So I want to advance this old line so that to my new time, 8:38, I want to advance it to 8:56 and see where it crosses my position to get a better position. So my first step in doing that is to see how far my estimated travel, my distance run, would be from 8:38 to 8:56. So 8:56 minus 8:38. That gives me 18 minutes. Is that right? Yes. 18 minutes. So that is my time. I have my speed of 5.2. What is my distance traveled? I'll give it this magic circle. 60 ST. What is my distance traveled?
5 nautical miles.
What was that?
1.56 nautical miles.
1.56 nautical miles. So that is my distance traveled in this time. And how we plot that is from where this first LOP crosses my track line. In this case, it's right at the beginning of my track line. So I am going to measure 1.56 nautical miles. That was really aggressive on my little line here. 1.56 nautical miles. And now I'm going to parallel that line, the same line I've paralleled So now that line would be 0838 to 0856. And where they meet, that is my 0856 R fix. Guys following along a little bit? Okay.
Yeah, no sweat.
Lost. Why
I
wouldn't,
have to say, I still don't understand the rationale of paralleling forward the original bearing. It just doesn't make intuitive sense to me.
me either. I don't know why the point where we're at wouldn't be the LOP against our new track. We're across
What was your question there? Why would it be at the start of the track line? Is that the question?
My question was, why wouldn't it be, why would we need to make that parallel shift of that 838 time? That
Yes.
838 bearing, because wouldn't our position necessarily be where the LOP to the hospital crosses our new track line? I guess I don't understand why that wouldn't be the case.
So this is not our position, right? That it crosses our track line much closer to our old position. So what we could do, which is essentially this as well, just because it happens to be like this, is create a DR position. So our 838, we did our math for a DR 1.56, that we said this is our DR for 856. Now, if we have one LOP, only one, wherever point along this line closest to our DR, that would be our estimated position. So I'm throwing an EP, an estimated position, in the loop here. In this case, this line that I drew is kind of perpendicular. So this would actually be our estimated position, but it's not always like that. So I wish this example was a little bit different, but I guess you could even imagine if, you know, our track line was further out, and we just had an old position that this was our 838 bearing, and we advanced it so that we can create a 856 running fix. What are your questions?
So once we advance it, are we looking for the intersection of the bearing to the hospital and the advanced line?
We're looking to our advanced line and our 856 LOP and our advanced 856 LOP, where those two meet. That's going to be our position.
Which I got it is pretty far from our course, right?
Correct. Correct. Yes. So we are, I think here is our position. So we are traveling, getting pushed even further offshore. So whatever was pushing us here is now pushing us even further.
that be offshore or like towards shore?
Toward shore.
Okay.
Sorry. Toward shore. So we want to come back and move away from shore. Which I'm assuming is what we're going to do in our next problem here.
So Bree, in practicality, this is really being used to help determine your exact position for course correction.
Yes.
This is why you would want to use this.
Yes. So I feel like I want to come up with a new example here. Let's do one on the whiteboard together.
It's a bit like you're making a triangle. You know that a parallel line will always progress along the line that it's at. It'll always be the same angle. So at time t equals 0 plus t equals n, you're going to have the exact same parallel line. It's as if you had taken a sightline fix of the LOP at that original time. You just advanced it further. And then your new LOP is going to give you the other side of a triangle.
Kind of like a parallelogram.
Yep.
So if we are cruising along, this was our old position at 12 o'clock. We are cruising along at 12:30. We get a bearing. Well, let's call this 12:05. See, I make it so close to this. I don't know why I do this. So I get an LOP. Then I'm still traveling and I get a bearing from this one. Let's call it over here at 12:35. So let's say I'm going 20 knots. So I would have traveled 10 nautical miles. I'm going to advance this line along my track line 10 nautical miles because that's how far I would have traveled. So I'm just advancing this line. Maybe let's go a little bit further. I'm even going to parallel it here. Try to get it. So here's our 10 nautical miles. I paralleled it up, and now where those two meet, that is my R fix. So I can see that I'm much closer to shore than I thought I was.
See, here's my question. So I've got the question. So you just a second ago rolled your parallel line along your track being the course you just ran, right? Theoretically?
Yes.
But now we find out that actually wasn't the course you ran, right? Because you're in this other position. So you've run it. So the last thing you did running the parallel was against a fictitious line. No?
I see your point. That line is basically because it's parallel no matter what, right? So even if I am over here
it'll still
at 10 nautical miles, our parallel line, well, my 10 would end up here, is still the same line, essentially.
So it doesn't matter. It wasn't really following the track. It was just moving its paralleleness.
It's just moving in the forward direction instead of paralleling it this way.
That clarifies. That's probably what I was hung up on. Was the
Our 10 miles. Now, yes, if we wanted to be more accurate on our actual course made good, that 10 miles might end up, here. So we might be a little bit shy. But that's going to be a smaller amount And again, we're assuming our course and speed. So this running fix does make those assumptions. We're assuming course and speed, but it shouldn't be too far off.
Okay, that's helpful. Thanks.
Okay. Okay. All right. Doing good so far. Okay. So we're here at 8:56. We flip over our paper or turn the page, whatever. And now we're going to actually try a bow and beam problem. So we're going to go back to our bow and beam. At 8:56, you drift for a while, deciding what to do. Is that what it says on your guys's? Does it say you drifted for 32 minutes at a speed of 1.7 knots at a set of 1.33 or 133? Or does it not say that at all?
No, yeah, it just says you drift for a while, but it doesn't expand on that.
Good, good, good. I am looking at the wrong one then. I was like, I thought I edited this. Sorry, I'm gonna bring up the actual one so I can look at it. Okay, at 8:56, we drift for a while. So then at 9:28, we decide to head further offshore on a course of, bring this out, of, so at 09:28, we change course to 160 PSC. You decide to take a bow and beam fix. So we see the building at Dana Point at, I guess we see it at 9:28. We see the building on the bow. And then at 10 o'clock, we see building on the beam. You're careful to hold your course, and we have a speed of 5.2. Can you get a good fix? Okay, so from this information, I'm not even gonna plot the other things just yet. I'm just gonna use this information to try to simplify it for us. Let me bring my Zoom back up. Wait, are you guys seeing my chart?
Yeah.
Yeah.
You are, okay. Sorry. Okay. So here's my information. My first step here is going to be converting that 160 to true. So let's do that. We're all masters at that now. 160. Our deviation is 0, actually. 160, 12 east, so that gives us 172 true. So 172 true. And now I'm gonna kind of do this the other way, not using my nav tools, because I haven't plotted that 172 line yet. So I want to find my 170, I'll draw it on here as a visual. 172. What is the bearing when it's a beam of me? What is that bearing?
90?
I'm going to subtract 90, or I add 270 and then subtract 360, or you can just subtract 90. So what would that bearing be?
Hmm.
172 minus 90.
82 degrees.
082. So that would be my bearing, because I know this is true. So this one would be true. That is my bearing. And then I want to know what my distance off is. And then I'm going to plot this. So to calculate distance off, 10 minus 928. Oops. That gives us 32 minutes. So distance is our question mark, speed 5.2, time 32 minutes. What is my distance?
2.8.
2.8. Was it 2.8? Yes, 2.8. Okay. So now when I'm going to do it on here real quick. So here's my building. When I plot this, I have my distance and my bearing. Those are the two data points that I'm using. So I'm going to plot it at 082 degrees, true, at a distance of 2.8 nautical miles. And that is my 10 o'clock position. And then I could plot from here, 172 degrees, true. So maybe I'll leave it. Let me do it on the chart now. But did this make sense so far? No, didn't make sense. Oh,
Yeah,
gosh.
you did it. You did the 172 minus 90 to find that.
082.
But could have just plotted the course at 172 and then used the corner of the triangle as well, right?
Correct.
Okay.
So we could have just done, we had our 856. Use this one. 172. There's our 172 line. Our building in Dana Point. We have our perpendicular line.
Why did that happen?
And then our distance off was 2.8. That was our position. So I did it two ways there. I did one converting that relative, and then I did one just using my tools to find that beam bearing. Either way is fine. What time was that? That was 10. What are we thinking so far? A lot to think about.
You know, I understand the bound beam. That makes sense to me, but the running fix, I still get confused with the procedure. Could you just go back to the very basic discussion of how what the theory is, and then do an example following that directly? Because I just don't see the relationship between what you originally told us and then what you're applying to get our actual location. It just doesn't make intuitive sense to me.
Okay, so let's make one up right here. We have an 856 position, and this is our track line of 172 at 5.2 knots, right?
Mm-hmm.
So let's make up, so 9 o'clock, we're gonna make something up. I'm gonna get a bearing from that 2JR buoy.
Yeah, well, you don't need to do it on the chart. What I would like to see is just repeat the basic description on the whiteboard on what the theory is for how this is applied, because it just gets too confusing with all the lines on the chart, and just simplify it with just the minimal number of lines and what the rationale is, because that's what I don't understand.
Okay. So here we had our 856. There's our track line. Here's our coastline. We have a buoy here. Let's see, I think we have like a hospital here or something. I don't know. A couple different things. Let's do it on one. Let's do it on one H navigation. So let's say at 9:10 we get a bearing. I don't want to use the bow and beam problem. We get a bearing from the hospital about right there, and that's at 9:10. I'm somewhere along that line at 9:10. And then at 9:30, let's call that 09:30, I'm somewhere along that line. So how I make this line valuable for me at 9:30 is by advancing it. So I've traveled 20 minutes. So let's say my speed's 10 knots. In 20 minutes, I would have traveled 3.3 nautical miles. So I'm going to advance this line .3 nautical miles. Let's go a little bit further.
This is exactly what I don't understand. Your original site tells you you're somewhere on that blue line that's labeled 0910. So what's the rationale for projecting the exact same line in the future? That's what doesn't make sense to me.
So it's also like at 9:30, we don't have, a different H navigation. Mm-hmm. So we're basically advancing that hospital in the direction that we traveled. We're kind of DRing it. The same course and speed that we were doing, 10 knots at 172. We're moving it along so that what we had in the past.
But we don't expect it to be the same. We know it's going to change. So why would you do that? We know the bearing is going to change. So what's the rationale for maintaining the old bearing? And that's what doesn't make sense to me.
Of creating this bearing?
The old one, yeah. Advancing it on a parallel to the original 910 bearing. That's why it doesn't make sense to me.
So it's just adding a little more information. So maybe I'm gonna throw in another one here. It was our estimated position. So if we're looking at 9:30 and let's say our DR for 9:30 was here. That's our DR. The point that is closest on our 9:30 DR line to the bearing line.
Could you pull your whiteboard up just slightly? It's out
Oh,
of
sorry.
Thank you.
I get distracted. That would be our estimated position. So if we're just going off of one LOP, then I had a DR line, but I'm probably not on my DR. If I have one LOP, I can see that I'm probably to the left of track. But if I use an old LOP, I even get more accurate position and say that I'm actually probably further left of track than I thought. Now, if I get an actual, you know, I saw the hospital here and now I can get the buoy, you know, maybe this is my actual 0930 fix, if I can see both of those. So we're kind of just getting a better fix, kind of building on that.
So it's not really a mathematical calculation. It's just a really rough estimate. Is that a true statement?
Yes, we're making that assumption of our speed and our course.
So it's not really based on geometry or anything. It's just a really rough way of making it a little more accurate, but it's not that accurate, is it?
So you can actually measure the accuracy if you're concerned about that. Because you're creating triangles here, right? You have your updated position, and you know that in any Cartesian plane, the lines are going to be the same. So if you know what your updated position is, even though it's a little bit off, you could create another fix, another line based upon your original track line. A parallel line is a parallel line is a parallel line. Doesn't matter where you draw it, right? So long as it's parallel to your original LOP. Therefore, you could take a look at what the difference is between the new line and the old line, and you can figure out how much of it you are off by looking at a new parallelogram that's going to be smaller than the one that Bree just drew. You're probably going to look at something that's pretty small as far as how much you're going to be off. We use this technique all the time with drones, which is kind of why this feels so natural to me.
Which application did you say you use it with?
With drones, as in order to get an exact fix with a drone, you take a reading at its GPS location at time index 0, and then you're not going to get another accurate fix for a set period of time because of the way that GPS works. There's also an error inherent in that positional fix. So you have to base it upon something else, and we actually use time of flight with cameras in order to do that. So you're looking at feature points between one point and another point. It's the exact same thing as an LOP. And then every 60 seconds you basically are creating a new LOP. So you're doing this multiple times a second with a drone.
Interesting. Very interesting. It's cool to see it in different fields as well. I might suggest checking out some other, YouTube videos on running fixes, or I know they talk about it in the CoNav book. Maybe when you hear someone else explain it, it clicks better for you. I don't know. I'm sorry I can't help you more on this one.
No, yeah, no, I appreciate the going over it again. Yeah, I think I need to do that so that it makes intuitive sense to me, because this,
Yeah.
I don't know. I also come from a scientific background. This seems really approximate to me. I guess I like things that are more exact, and seems like a kind of a shot in the dark, but it is an improvement, but it's not a huge improvement.
Yes, and that's what we're trying to take information in and get our best possible, position. And even if we don't have that perfect simultaneous fix of all, spread apart equally from each other, we can still get a little bit of information, and it's applying those old data points to so it's not just a DR position, just a dead reckoning position. But
Could you also use a handheld compass to get a more accurate fix?
Yes. So you could use your handheld compass and do a simultaneous fix. And that would give you, a solid visual fix at the same time, not LOPs at different times. So
Is that a faster way to formulate that information than going through the formula?
Yes, but I'm going to say back in reality, it might not be perfect, where you might only have one aid to navigation, or it's really foggy and you can only see one, and then it's a long time before you could see another one. So you might not have that perfect spread of two aids to navigation at a perfect 90 or 30 degrees apart from one another that you can get a visual bearing off of. So most of the time at sea, we're not in this ideal condition and we have to adapt. So this is one way that you can, adapt to find a position that is, a little bit more than just a random, I guess I'm here, and using the information that we have.
Understand.
Okay, cool. So our last one on this worksheet is a visual range problem. So here we are at 10 o'clock. The weather is still a factor, so we come left again to 10. Oh no, we come left. We were going to the right, so we come left to 100 PSC to head into Dana Point until the fog clears. So now we are headed back into Dana Point. We're maintaining 5.2 knots. At 10:25, we see a visual range of the building that we were looking at and buoy R. And then we also have a bearing of the cross. So we need to convert those data points, our heading and our bearing, to true so we can plot them. So at 10:25, or maybe at 10 o'clock, let's see, we change course to 100 degrees PSC. At 10:25, we see the building and 2 SJR in line, and then we see the cross bearing 038 degrees PSC. Okay, so let's see, can we see ourselves on here? Yes. Okay, so now I want to plot my position using this information. So first I am going to convert this and this to true. See there. So I have C, D, N, B, T. We have my heading, and we have the cross. So my heading was 100. 038. My heading was 100. Five east. $12 east is our variation. That is 117. This is 550. So this would be 117, and this would be 055. So I converted my PSCs to true, so now I can plot. So let's go back to here. I'll do it on here. I'll do it on whiteboard again, but I'll just do it on here real quick. So I am steering 117.
How do I get that? No?
There's my 117. And then I see the building and the buoy in line. So all I do here is join those two. And I am somewhere along there. And then this cross is bearing 055.
I got 053. I might have made a mistake there though.
I might have made a mistake here. 38 was in our
I got
problem.
deviation is 3E.
So
Deviation
deviation
3?
again goes with your heading. Your heading was 5.
Oh.
Oh, okay.
Yep.
That's
What am I doing? 055. So I am very close to this buoy. So put it on here. Okay, so when I plot these, I plot the building and the buoy in line. So I just draw them in line. That's why I like visual ranges. You don't have to use any tools, no measurements, you just draw it in line. And then we had a cross over here. That was bearing 055. So we have a position very close to that buoy at 1025. And it asks us, what is our position? And then it also asks us, how far did you cruise in between fixes? So, in between fixes, that was a straight line. This was our course made good, speed made good. It asks us how far did we travel and what speed was it. So we measure how far we traveled. I got 2.9. And then we're going to convert distance is 2.9. Time is 25 minutes. What was my speed made good? We're looking for speed made good. Speed, so we'll call it 7 knots. So our speed made good was 7 knots. All right. How you guys doing?
I was close.
Okay. That's good.
Frustrated, but looking forward to watching the video.
Okay, good.
I wouldn't say good.
All right. Well, I hope it makes sense for you guys on the video. I guess we had trouble tonight figuring out what I was talking about. I don't know. I don't know what else I could add in. The homework is essentially the final project, which you could do next week. I'll be here, or you can do it beforehand, whatever you guys want. And all of these types of questions will be on that final project again as well. There'll be the running fix, the bow and beam, ETAs, visual lines, all that on the final plot as well. So try that out, see if it, maybe sleep on it, try it again sometime this weekend, see if it makes a little more sense to you. And that's all I got for new information.
Hey, Captain, question for you. Under assignment 14, the paragraph, the fog starts rolling in. After plotting an 838 fix, you decide to steer for a course of 140 PSC. Did you change that? Is the correct PSC course 160 or is it 140?
I am using an old sheet, so it has probably changed.
So what course would you like, PSC course would you like me to use to try and triangulate towards the answers to figure out how this works?
And what number was that on? That was for 14, the last one that we were doing?
Yeah, assignment 14 between question 7 and question 8.
Wait, 7 and 8.
The paragraph that starts with the fog starts rolling in.
Yep, I'm.
and I remember while you were going through it, you read the course 140 PSC, and then there was a question, or maybe you raised the question about, wait a minute, is it 140 or should it be 160?
It should be 140.
140, okay,
Yes.
got it. Okay, thank you.
Okay.
Hey, Bree,
Yes.
do we still have time to learn about danger bearings?
Yes. Great. You remembered.
Thank you.
Yes. Danger bearings. Let's see. You guys are still looking at my whiteboard here, right? Yeah. Okay. Let's draw. Lighthouse. And maybe here's a wreck, some shallow areas. Let's make it a little bit. Okay. Let's see here. So, a danger bearing is if we have a danger. Here's our danger. What I want to plot, if I know I'm going to be navigating somewhere around this danger, is a danger bearing. So what a danger bearing is if the edge, so somewhere the closest I want to be to it from a aid to navigation. So I'm going to use a buoy or a light, whatever it is. I'm going to draw a bearing line. So roughly, I'm going to call this 100 degrees true. Rough 100 degrees true. So if I am over here, my bearing to that light in question is going to be less than that 100. So in this case, it might be 080. I'm on this one, it might be 045. I'm on this one, maybe it's 090. Somewhere over here, if it's less than 100, I'm in the safe zone. At any point that it's more than 100, it doesn't mean, hey, I'm running aground, we need to stop everything. It just means that I'm closer, I'm north of my danger bearing line, which means I should get a more accurate position somehow. I should use the, tools in my toolbox, whatever, bow and beam, running fix, visual fix, GPS, radar, whatever you have, to get a better position so you know exactly where you are. So just by getting a bearing of this buoy or this light that is more than 100, you know that it's possible you could be in a danger area. You could be somewhere in this zone. So that's kind of the danger bearing simplified. Does that kind of make sense to you guys? So with your danger, well, let me do another one. That if you're steering by hand, let's say we're cruising along the coast, here's the coast. we're going 0, 0, 0. When you're steering by hand, you might want to, tell the helmsman or something, don't steer anything more than or less than or to the left or right of 0, 0, 0. So that way, as you, steer, you're steering always to the, veering away from danger if this is the coastline or this is the danger area. That as you're steering, you always want to go nothing to the right or nothing to the left of a certain course. So you're not kind of going back like that, but it's more like, I guess it'd be more like that if you definitely steered nothing to the right of 0, 0, 0. But those are the two ways that we can use that less than or more than, which you might see is that that danger bearing. We could look at it the other way. Here's your danger area. Here's your light. So you're bearing to it, or let's do north of it. Woo. Here's your dangers. So let's call this line 260 degrees true. So if I am getting a bearing of 300, or I would be getting a bearing of 250, that more than is dangerous. Or no, the less than, in this case, anything less than would be dangerous. No good. The more than 260, we're in the clear. We're somewhere along this area. Kind of making sense? All right.
Pretty straightforward.
Yeah, just something to have in the back of your head if you know you're going to be around a danger area, to be like, oh, I always want that, that lighthouse or that point or the end of the jetty or something to be bearing a certain degree. So, so you're not drifting into it. It can be deceiving that way. So, yeah, that's it. Stop our share. Check out the videos online. Keep practicing, and I'll be here next week for more questions, but again, no new information. That's all I got.
Well, thank you, Bree.
Yep, thank you, Bree. Good night.
Thanks, Milo.
Yeah, thank you.
Thank you.
Bye-bye.
Thank you.
Have a good one.
You too.
You too.
Thanks, Captain.